Hello! Welcome back to another fun, exciting Miss Scully video. I know you guys were waiting in anticipation. This is not Unit 6, but I didn't change anything. Oh well. This is Unit 2. If you can't see, I'm doing 2 on equations and inequalities. Today we're learning absolute value inequalities. Ta-da! So absolute value inequalities is very similar to absolute value equations, meaning that you're going to have to do a split again. But like equations are to inequalities, you do have a couple extra rules that you need to keep in mind. So let's review what absolute value is. Absolute value is the distance a number is from 0 on the number line. So it's always helpful to keep that in mind. Okay? And next one. So like solving absolute values inequalities represent two different inequalities. Is that all I have on this page? That's weird. Each absolute value inequality represents two situations that can show the same distance away from 0. So left side, right side, like normal. The first situation is an inequality that is written as what is given without the absolute values. So that's when it's like similar to when it said like equal to the positive number. You're going to write whatever the inequality symbol is to whatever number it is. Okay? The second looks like the first. However, you have the flipped inequality symbol and the opposite sign of the number. Okay? You have to change, so like we did for equations, you had a positive and a negative. You're going to have the positive and negative number, but you're also going to have opposite signs for the inequality. So one will be greater than, one will be equal to, or one will be less than. Okay? If the inequality sign is less than or equal to, when you have the absolute value, it represents a compound inequality. So that's what remember, compounds just mean you have more than one inequality. And that's what we're doing when we do a split. So it's going to give you a compound inequality with the word and. If the sign is greater than or equal to, you have the inequality that represents a compound of the word or. Alright? And there's a way to remember it. I don't think I put it on here. So the way you remember it is greater than, greater or than is your or word. Less than and less than is your and word. Okay? I know it sounds really stupid, and it probably is to anyone watching. But it helps you remember it, and that's all I care about. Yay! Alright, so, example 1. We're going to do 2. Okay? So, like the absolute value equation, we always need the inequality, the absolute value of the inequality, to be by itself before we can do these splits. Okay? So it says rewrite the absolute value inequality as a compound inequality. So we don't actually have to solve it, we just have to write it as our two inequalities. Alright? So this one we have the absolute value of 8 minus x is less than 2. Less than means and. So when we write this, what we're going to do is we're going to have the 8 minus x less than 2, like it says. So all we have to do is lose the absolute value symbol. Then we are going to flip this sign and make this 2 into a negative 2. Okay? So notice how once we split it, there's no absolute value symbols. Alright? These are the two inequalities we would solve. You can write it with the and statement when you split it and just leave it like that, or you can smush them together. They have the 8 minus x in common. So you just put the smaller number in the front and the bigger number in the back. Okay? Either one was totally acceptable. Alright? Now this is the absolute value of 1 minus 2a is greater than 11, so greater means that you're doing an or statement. So you split it, so one of them is going to be just 1 minus 2a is greater than 11. The other one, though, you turn it around, you flip this sign, so it's going to be 1 minus 2a is less than negative 11. Okay? And we can't smush it together, so we just leave it as is. And then those are the two inequalities we'd solve. You guys are going to try this one on your own. So just try writing it as the two inequalities, okay? Alright. Example 2. I'm looking at the examples as I go. On a separate page. Yep. So, example 2. We're going to do, we have to solve this absolute value inequality. Well, we have to get this inequality this absolute value is already by itself, which is great. So that means we can split it. It's greater than or equal to, or, so that's what we're going to split it into, an or statement. So, first inequality, 1 minus 2p greater than or equal to 9. Second one, it's going to be 1 minus 2p, flip the sign, so it's less than or equal to, and change that 9 to negative. Right? So those are our two inequalities we're going to solve. First thing we're going to do is subtract 1 from all of it. So now we get, negative 2p is greater than or equal to 8, and negative 2p is less than or equal to negative 10. Divide by negative 2. So because we're dividing by a negative, we have to flip the sign. So we get p is less than or equal to negative 4, or p is greater than or equal to 5. Okay? And if we had to graph it, that's easy to graph, so we don't have to worry. So, b, or this, try on your own. Here's my hint for you. Okay? Flip this whole inequality so the absolute value is in the front. So it looks like this, okay? That way you can tell what kind of statement it is. Because you always need to have it so it's the absolute value, inequality sign, number, to figure out if it's an and or an or statement. Okay? So solve this one. Alright, now what if all this stuff happens? What if the absolute value of 2x minus 3 is less than negative 4? Can an absolute value be less than a negative number? Well, the only thing less than a negative number is more negatives. So, an absolute value can't be less than a negative number, so that's an example when you're going to have no solution. If the absolute value is less than a negative number. What if it's greater than a negative number? Well, can an absolute value be greater than a negative number? Yeah. So that one's the one we need to solve. Yes, it could equal negative 2 or whatever, but it probably won't, because that doesn't make sense. So, even though it's still a negative number there, it's talking about stuff bigger than negative 4. So, we have a lot of numbers that are bigger than negative 4 that can work for this. Okay? Example 3, we're going to go ahead and solve these inequalities. So these two we're going to do together. This one, though, you guys are doing on your own. So to solve them, we're going to go straight in. Absolute value already by itself. Great. We can go ahead and solve it. Perfect. So it says the absolute value is less than 13. Less than is an and statement. So we're going to split it. So it's 8 minus 3m is less than or equal to 13. And 8 minus 3m, flip the sign, is greater than or equal to negative 13. Okay? So, you can write it just like that, so it's a smushed one. Or you can write with the word and in between. It's fine. But when it's smushed together, I just go ahead and work on all three sides. So first I subtract 8 from both sides. I get negative 3m is that compared to negative 21 and 5. So I go ahead and divide everything by negative 3. Now, by dividing everything, I flip my sign. Okay? So I get 7 is greater than or equal to m, which is greater than or equal to negative 5/3. That is an ugly number, but oh well. Here's the graph. So, it's an and statement, so I'm going to go from 7 to negative 5/3 is negative 2 1/3, so a little bit right here. So, oh wait. Yeah, it should be. No, it's negative 1 2/3. Just kidding. So that's my and statement. They're both close circled because they're equal to's, and that's what I got. Okay. Now B right here. So it's already by itself, so I can go ahead and split it. It's a greater symbol, so it's going to be an or statement. I'm going to write 4r minus 4 is greater than 40. And then my other one, I'm going to do 4r minus 4, flip this sign so it's less than, and change this to negative 40. Okay? So now to solve it, I'm going to add 4 to both sides here and here. So I get 4r is greater than 44, and 4r is less than negative 36. Divide everything by positive 4. We get r is greater than 11, and r is less than negative 9, or. Okay? So for this, I should have two separate inequalities. Greater than 11, which is way over here. There's 11. And less than or equal to negative 9, so way over here. Okay? Those are my two graphs. You guys are going to try C on your own. All right. And graph it on a number line. And we're going to move on to example 4. All right, solve and graph. So example 4, so this is one where I have to isolate this absolute value. So we do it just like we do with equations. We have to treat this like a variable kind of, and get rid of the stuff behind it. Like behind it and in front of it, all that stuff. So I'm going to get rid of this plus 5 first, because SadMeg says I have to do it before I need to get that absolute value so I can split it. So subtract 5. I get 3 times the absolute value is less than 9. So now I can divide by 3. So I get the absolute value of 2x minus 1 is less than 3. Now that the absolute value is by itself, I can go ahead and split it. So we have 2x minus 1 is just going to be less than 3. And it's less than, so it's going to be an and statement. And then the other one will be 2x minus 1 is greater than negative 3. Okay? So I can go ahead and solve for x just by adding 1 to both sides. All sides, really. I get 2x is greater than, or less than 4, and 2x is greater than negative 2. Divide everything by 2. I get x is less than 2, and x is greater than negative 1. So my graph, which is right here, it's an and statement, so they should connect. So I'm going to have an open circle on negative 1 and an open circle on 2 and connect them. Okay? Then you guys are going to try this one on your own, and that's it for the video. If you have questions, please write them down. Please ask them in class. I want to go over the stuff with you. Okay? Other than that, I will see you guys next time. Have a great day. See you later.